All right, so let's take a look at explore number 2. Still with parts of the atom. The question we're trying to answer here is how can isotopes of a given element be identified? So if you take a look at the different topics here, we have a section on isotopes. And if we take a look at a picture here, we got a picture of hydrogen. And there's 3 different isotopes of hydrogen. We have protium, which has 1 proton, no neutrons. We have deuterium, a proton and a neutron. And we have tritium, a proton and 2 neutrons. So in this case here, notice that all 3 of them have only 1 proton. That constitutes its identity, right? And if we continue to scroll down, that's really it. Very brief. This is going to be really a quick lecture series. But do take a look at the video segments. You've got a video on isotopes, a video segment on isotopes of hydrogen, and you have a image of helium isotopes. This should all kind of check those out. Those will kind of help cement your knowledge on isotopes. So Roman numeral 1, let's go and draw our lines. And today, again, is Monday, 10/9/23. I'm just writing this date down because this is the date that I'm actually creating these notes. And our essential question is going to be in green there. And I have put this into your formative as an assignment. So you need to answer this question under Explore 2. How can isotopes of a given element be identified? So how can isotopes of a given element be identified? Question mark. Okay. I used the green kind of to identify the main idea here. Not all atoms of a given element are completely identical. So let's write that down. Not all atoms of a given element are identical. So you can have gold, but you can have different versions of gold. You can have oxygen, but have different versions of oxygen. You can have carbon, but different versions of carbon. Remember, an element is really just a collection of atoms, but they're still a pure version. If it's gold, it's going to be only gold. If it's carbon, it's going to be only carbon. So that's the important thing to appreciate there, is that an element may refer to a collection of atoms, but they're all going to be consistently the same type of atom. An atom by itself is just a pure atom. Okay, so this brings into our conversation about isotopes, and we've already kind of addressed this. Isotopes. And if we were to click on that, remember, always click on these things there. What is an isotope? An atom of the same element with the same number of protons but different numbers of neutrons. Has the same atomic number but different atomic mass. Okay, you need to know that. An atom of the same element with the same number of protons but different number of neutrons. It has the same atomic number, of course, right? Because that's the number of protons. But a different atomic mass. Why a different atomic mass? Well, because isotopes can have different numbers of neutrons, and that's where that's going to contribute to a different atomic mass, because varying number of neutrons. All right, so we can go ahead and close this guy up here. And let's take a look here. So here we have our hydrogen as an example. Example is hydrogen. We have hydrogen with just one proton. We call this a protium. We have a proton again, but we also have a neutron, and this is going to be our deuterium. And then we have our third example is going to have, again, one proton because that's its identity, but this one's going to have two neutrons. Okay, so this is tritium. Okay, so in this example here, all have the same number of protons, but different numbers of neutrons. And that's simply what this is what is going to constitute isotopes of the same atom, or we could say of the same element. So in this case, how many are there? There's therefore there have three isotopes of hydrogen. Okay. Not talking about charge at all. Not talking about anions or cations. Not talking about the excess or of electrons or fewer electrons. We're simply talking about protons versus neutrons. Okay, and that's kind of it, really. Oh, just a little side note here. Stable atoms usually have equal numbers of protons